We'll go straight on into our first talk. We've got Frederik from Amazon Web Services, who's going to be talking about peering.
Hello, good afternoon. So I'm Frederik Korsback, the second fastest talking Swede in the room, I guess. I'm a senior infrastructure business developer for Amazon Web Services. So basically a BGP guy. I take care of UK and Ireland, Scandinavia, the Baltic states, and a couple of the countries to the east of those states as well. And I'm here today to talk with you, like a general update on peering with AWS, what it means, and some of the common misconceptions that you might be aware of. So for the one that do not know what Amazon is, so we're an American technology company. We have an online shopping experience, which some people might have used to buy some books. We also operate cloud. We have Prime Video, we have Jeremy Clarkson, Amazon Music, Fire tablets, and a whole bunch more. Obviously, very well established in this country, but this is more like a generic slide deck, so in some countries I actually have to explain what we do. So if we're looking at it from a network perspective, right? Like what do we actually serve from the 16509 edge network? So the first thing would be kind of the cloud part of AWS. So today we span 87 availability zones, which then translates into 27 geographic regions. The one in London, we have in Dublin, up where I live in Stockholm, called EU North. We just opened up in Switzerland as well in Spain, and we're expanding across the globe. So these regions are fairly large builds. Like every time I go into them, I like it's jaw-dropping experience. Like it is, I've never seen as many racks in the same place as when you go into those regions. So these are, these take like 5 to 6 years to build. So this was a long time ago that we started to plan this, and we're continuously looking at what to do here. So today in the regions, we run roughly 200 or so IT services, everything from like EC2 and S3, which I guess people is at least somewhat aware of what it is, like storage services and virtual machines. But actually, there's a lot more today to what's being run in the cloud. There was the map. So this is how it looks like today. Everything except the region in Israel, in kind of this region, is launched already. And we have our own conference next week, reInvent in Las Vegas. I'm sure there will be more news on what's to come there. So if we go deeper, I'm an edge guy, right? So I work with the edge network, and the edge network. And what do we serve from there? Like what is actually existing inside the edge network? So the first thing that most people would see is what we call the CloudFront CDN. It's today have grown into be a multi-petabit scale type of CDN. And it's used by thousands of customers. It's everything from like obvious things such as Prime Video, but also like your Slack images that you're sending to each other currently is probably coming from a CloudFront CDN POP. On top of this, we also have a couple of security services. WAF, I guess, is the most prominent one with web application firewalls. There's DDoS stuff and DNS stuff within the Route 53 kind of product umbrella. There is something called, or at least we call, acceleration services, which is relying mostly on any cost. It's quite popular in the gaming world. It's quite popular in anything that is DDoS sensitive to kind of be able to utilize our Anycast network for both outbound and inbound traffic. Today, you also do computing at the very edge, which sometimes refers to as serverless. Essentially, you can run code on top of our CDN boxes. And that's kind of the core of the services that we do in the edge. And then I guess the first common misconception is that AWS Direct Connect, sometimes also referred to as Cloud On-Ramp, for example. Like what is this and why do we need to pay for it, whereas peering is free, right? So Direct Connect is available in select POPs here in the UK for sure. And it can be consumed either direct through us, so that is typically for the medium to large size type of customers, or through a connectivity partner. I think here in the UK, we have roughly 20 or so partners, whereas LINX being one of them, and most of the big ISPs as well in the UK, where you as an enterprise company can have like the cloud on-ramp directly to the cloud. And what this is that it comes with MACsec, it comes with SLAs, it comes with QoS, it comes with a price tag of some sort, And it's not really the same thing as regular peering. This is what you want to use to basically come inside your own AWS network infrastructure, sometimes referred to as the VPC. So that's a common thing, and it's always when we speak with customers and peers, is like, do we need both? Can we just use one or the other? It's like, they're not really the same product. Like, even though they both kind of rely on BGP into the edge network, they're not the same thing. They are used for completely different purposes. It's fairly common that we get approached, like on conferences such as this, for enterprise companies, and they're like, oh, right, let's set up some eBGP peering over LINX because that is free instead of the direct connect, and they don't get the service that they would expect to get, right? So it's this is a thing that we just have to navigate, and I guess that's true for most big hyperscaler cloud that has similar services. So looking at the edge network in Europe specifically, we are, I'm not sure, somewhere around 100 or so POPs in most, I would say, established interconnect metros in Europe. We have a couple of more locations which we are targeting for the future, but at least for this year, we've been mostly in scaling in place, so scaling in metros where we already have a presence. Because there isn't that many more sensible interconnect metros left in Europe outside of what we have. So some of the new things that is coming for our network or in our network, I would highlight two things. So first, it would be the local zones, which are baby clouds, or some of them are not very baby either. They are quite big as well. But it is like single availability zones that we can deploy much closer to the end user. I believe this year we are about to launch 15 of them in Europe alone. And last year at reInvent, our CEO or our CTO presented, I believe, 36 of them globally. And the reason for this is that we want to be closer to our end user, or rather our customers wants to be closer to internet end users for several reasons. Two of our kind of anchor tenants or anchor customers for this service is Dish in the US, which is essentially a virtual mobile operator in the US that do not own their own infrastructure. Everything is kind of built in the cloud. So they are using all of our local zones to aggregate compute. Netflix is another good use case where they were actually the first customer in the world to utilize local zones to be close to whatever the actual move is being made. So they were the first user of the local zone in Los Angeles, because that's where movies are being made these days. Wavelength zone, which in my opinion is the worst product name in the world because it confuses with like regular wavelengths. I'm not sure who made it up, but now it's stuck and we can't get rid of it. It has nothing to do with typical DWDM wavelengths. So what it is a partnership model together with ISPs, where we essentially deploy compute capabilities inside their 5G aggregator nodes. So MEC in mobile operator language. Today, we have roughly 5 ISPs, whereas one of them being in the UK, which is Vodafone. Verizon, I believe, was the first one, where we have roughly 40 or so zones already up and running. So kind of how this works is that customers can go in and essentially buy VMs or whatever resources is available on this inside a 5G operator's aggregator site. So you can buy a VM in Verizon Jacksonville, for example, and run your workloads from there. We have a couple of interesting use cases there with customers such as Samsung in Net4 doing autonomous driving and IoT type of workloads in that kind of application, which I think is pretty cool. So in the EU here, I believe this is 15 or so of these blue squares. That's where we're deploying right now. Most of them are targeted to be launched this year or early next year. We have a couple of more down our sleeves, but we'll see kind of how this works. From a peering and interconnect perspective, this will use existing infrastructure. So there will be no additional new capacity by anyone that needs to be added. So we will use existing over PNIs or IX or transit. So hopefully it will move a little bit of traffic away from the big, I would say, mega regions such as London or Frankfurt, and take it a little bit further out, closer to the end user. That's at least our thought about it. Let's see if customer likes that too. And then we have some general updates. So this is kind of what we as Amazon Interconnect people are thinking about right now. So the first thing would be peering concentration, I would say. And especially in this case for IX-based peers, might not be a popular opinion at this conference, but I think it's something we need to talk about, where we have actually been disconnecting a couple of IXPs the last year, one of them being LINX Manchester, for example, where we see low local growth and low local coverage, and I highlighted the word local here. There is a lot of IXs out there in the world that are growing in terms of absolute numbers, but they are growing with, I would say, fake news numbers, right? Like it's traffic that is coming from somewhere else, but that just happens to be run across the IX to kind of boost the numbers up. We are not big fans of that. We like traffic to go local. We want to shorten the bit miles at every single possible instance. And for us, IXs is the smallest capacity types. It is roughly 2% of our where we send traffic across Europe, but it is, in terms of cost, one of the biggest ones. So this is what we are thinking about, and it's something that I think people should be aware of, that this is happening for us, but probably also for other companies too. We are still not remote peering anywhere. We are actively looking at everyone that comes in and sends us peering requests and see if they are local. If they're not local, we need to figure out if the IX is actually the best way to reach them, or if perhaps a transit would be more sufficient. And we're still not using route service anywhere, because we are not an open peering network. We are selectively peering with networks where it makes sense. Event focus has been another thing that all of us has to work with a lot lately. Amazon, as a company, has been buying a lot of media rights lately and a lot of content acquisition. Here in the UK was one of the first big ones with the Premier League not acquisition, but the rights to certain games for Premier League. This has certainly not stopped. Thursday Night Football, I guess in sheer numbers, is by far the largest one, where we are exclusively streaming TNF on Thursdays in the US on Prime Video. We have also bought rights to Champions League here in the UK, as well as in Germany, and there's other countries coming too, La Liga in Spain, and a whole bunch more. And on top of this, we also need to add our big customers that are doing the same thing, right? They are media rights or sporting rights. There is, everyone is producing their own movies and their own series and all of that, right? So all of that happens simultaneously, which means that we kind of need to work with ISPs in a bit different way. We are much more closer to key ISPs than we were perhaps 5 years before. We need, with some ISPs, we have essentially weekly meetings all year around to figure out what to do. Another cool thing or interesting thing is that the new norm for both our internal workloads, such as Prime Video, but also external, is that 4K Ultra HD HDR is the new norm. That is what everyone assumes that people would like to see. And so this, if we translate this to megabits, is anything from like 16 up to 27 megabit per stream, which puts quite a lot of strain on some networks, which we all need to, work around. Speaking specifically about UK and Ireland, because this is, it's the market I take care about. So looking at London, where Equinix Slough and Telehouse North will be our main hubs going forward. It's actually been like that for quite some time. Before the Premier League here started, before kind of the World Cup paused it, we rebuilt both sites into full 400 gig capable sites. And we've been trying to migrate peers as they're able to into 400 gig interfaces. And I will talk a little bit more later on 400 gig and kind of the cost benefit analysis of that. But this is what we will do going forward. This will be our two primary sites. We obviously love LINX PI, and we're happy to pair with anyone that makes sense over PI if possible. Then Interaction City Campus is for us an optical extension, which means that we do not have actual routers in that site. However, we do have optical. Today, this is 100 gig only, so no 10 gigs and no 400 gigs as of yet. It is then, of course, not a preferred site for us, given that we have to, there's a lot more cost involved for us to build to that site than, for example, Telehouse. Sovereign House is an IP POP, which means that we have routers in Sovereign House. However, it is not a preferred site either. We will, at least for the time being, not convert this into a 400 gig site. It will be still like a 10 and 100 gig type of site. And I think what I would like to do is to eventually sunset that site completely. We'll see about that. Harbor Exchange, same thing, optical extension for us. So we have DWDM there for the time being only 100 gigs, so no 10 gigs, no 400 gigs. It is not preferred, but for specific cases, we are happy to look at that, of course. But it is not, you know, we're not giving away ports there like free candy, right? Then since we're at LINX, let's talk about LINX. So we are more than happy to upgrade to 400 gig, and orders have been in for quite some time. And hopefully we'll very soon be ready with all the conversions on LON 1 to 400 gig to be able to do that. LON 2, I saw that in the program there will be some talks about how LON 2 is progressing on 400 gig, and I'm more than happy to buy those ports immediately as soon as they're available. So we can move away from 100 gigs because we don't want them anymore. We want 400 gigs. Manchester, so MA3, if you've ever been there, it's not a great site, or if you tried to build some interconnect in MA3, it is not very easy. We are essentially alone out in the forest, so we have to rely a lot on dark fiber that is roughly 10.1 kilometer long. So every time we need to troubleshoot and polish connectors and try to find that last dBm to actually get the links up. So we have a mix of lit waves and dark fiber coming out from MA3, but it was the only place that could fit us. Because typically our main problem, like the reason why we select certain sites and why we build in certain places is typically space. Like almost no one can fit us. Like when we go into somewhere, we need like 40 racks as like a day one type of build. And those are typically not available in sites just as, I don't know, MA1 or MA2, right? MA4. So MA3, where we have to do, now MA5 is available. I believe we are the first tenant in there. We will look at migrating peers, if possible, into MA5. It is in a much more better distance towards the old school connectivity hub in Manchester, which would be the city campus. And if anyone thinks about building out to MA5, we'll be more than happy to move ports over. We have brand new equipment there. We're doubling up on CDN capacity in Manchester. Given that today we're roughly 95% of the load in the whole UK comes from London, which is not a great place to be in. It's only roughly 5% coming out of Manchester, and we would like to prop up Manchester a bit more to make sure that especially the northern networks gets capacity closer to them, right? So please come meet us at MF5. If not, I will come meet you at the old campus. We are going to buy dark fiber from MF5 into the city campus. And hopefully we can launch it roughly after the planned network freezes ends here at like 15th of January. Hopefully that site is up and running. Dublin, let's speak about that too. Dublin is a weird place and where we are essentially not having any routers in any sensible data centers where other people are. Like these are our own private facilities that is not very close to anything else. So we have to rely on our dark fiber network in Dublin. We'll try to come pick people up where they are in Dublin, but sometimes distance is a problem. We're also happy to pair with people at LINX, of course. And there will be more, hopefully I can go to the LINX meeting as well in a month, and we could talk a bit more about what to do in Dublin, given that we cannot fit in any of the data centers there either. So we need to be in basically private housing in Dublin to fit anywhere. So that's also why we are very interested in, for example, ZR technologies as well, like 400 gig ZR in Dublin would be cool to do. And for the rest, so come talk to me like after this event or at the coffee break or tonight or tomorrow about embedded caches. There is some interesting news about that, especially for the UK, and we will work more on that. All right, I promise to talk about 400 gig, and you know, AWS is not a very public company. Like we typically don't talk about how we build things, and I'm not really allowed to either, but I'm allowed to, you know, have a little bit of fun, right? So kind of how we did it before was to have refrigerator-sized routers between the cloud and the peers. This is how most people have done it over the years. But actually, you know, starting 5 years ago, we started to move our data center technology out to the edge. So our 100 gig platform is actually not a refrigerator-sized router. It's a lot of small routers. And you can, like very, very smart operators, you already figure it out. Like when we terminate your port somewhere, let's say you have 10 times 100 gig ports with us, you are probably terminating in 10 different routers on our side. And we will continue to do that. And now on 400 gig, I'm not sure if it's even visible on the screen, but every single router we have in our 400 gig platform is one rack unit, and all of them have 32 by 400 gig ports. And this plays in quite nicely on how we think about 400 gig. Like we have been a big user and supporter for 400 gig for a long time. Like even in 2020, we had our first 400 gig native VMs to sell to customers. That was based upon the NVIDIA stuff for like machine learning. So like we've been in this game for quite some time. And as always for us, the data center people always gets the cool stuff first. And then the backbone people gets the cool stuff. And we in the edge team, we get it when it's not cool anymore, right? Which is kind of where we are right now with 400 gig. So being here talking with you, like we are in the edge migration stage. Like the data center has been 400 gig for a long time. The backbone has kind of been there for a long time. And now it's time to also bring it to the edge. So in 2020 onwards, we will convert all these sites to 400 gig. And that also means that like we're not putting in new line cards or anything like that. We are basically scrapping the whole sites and building a new one like right next to it, and then just move all the cables at once. And for the ones that are appearing with us in London, you've probably seen this. We did Telehouse a month ago, and I believe we did Slough 1.5 months ago. And essentially, we took down the whole site and moved everything at once, that's a lot of fibers to keep track of. And mostly, I think we were fine. It was very few mistakes, which is also probably the reason why I'm not getting like tomatoes on me right now. So this is how we do it, right? Like because we don't have any chassis routers anymore. We stopped with those a long time ago. So we take everything out and put everything new in. And I started this presentation, like, I believe it was for peering days in Greece, was the first time I had it. So, and I edited my slide there at basically when I was presenting about optical standards on 400 gig. There was another vendor there at the event that was talking a lot about 8-lane 400 gig. And I couldn't believe my ears when I heard about it, because like, I truly do not believe in any 400 gig technology that is not based upon 4 lanes. So everything we do is based upon 400 gig LR4, at least for external peering. Internal stuff is FR4, which also means that since we do breakouts, obviously not all of our servers or all of our stuff is 400 gig capable. So we do breakouts into 100 gigs. So we use 100 gig LR1, for example. We're not going to do any 8-lane optics, as I said. We're also not going to do any of the 2-kilometer options that I know that some others are doing. One of our biggest costs in the network is sending remote hands to fix stuff, and losing a lot of that precious DBM on every single peering link is simply not worth it. So we will not do any, because we think that 2 kilometers optics is long-term more expensive than any 10-kilometer options. And I'm more than happy to show you the numbers on that after this presentation, if that's something you're interested in the coffee break. So in this case, speak with your AWS representative about your plan for 400 gig. For the UK and Ireland, that's me. We have some of our German friends here too. Then it's not me, then it will be someone else, but I'm more than happy to refer. And that also leads us into the 10 gig and 100 gig discussion. So 10 gig will essentially be sunset from us. Like we will not be supporting 10 gig PNIs going forward. And the reason for this is since we only have a single platform for everything, to be able to produce a 10 gig port, we have to sacrifice a 400 gig port. That is the only way we can do it. We will not bring up like an old MX router from the trash bin and put it on the side and create a whole bunch of 10 gig ports. That is simply not how we operate. So what we have to do is to take a 40 gig QSFP plus, the breakout optics, put it inside a 400 gig port, and then only use one single 10 gig to connect to the 10 gig peer. So, I mean, that is crazy, right? Because we do not allow that we, for example, share faith in between peers on a single optic. So we cannot do breakouts to different peers. I would be okay doing breakouts to a single peer because then at least we share faith with the ISP. But doing it to multiples, it is, in my book, is not okay. So we decided to not do that globally. Obviously, in some markets, Africa, for example, 400 gig, that's not going to happen for quite some time. So there we are building with kind of the old style platform. But US, Europe, this is the only way forward, which means that 10 gig type of networks, then probably IX is the right type of connectivity platform for that type of workload. If you have, let's say, 2 gig, 3 gig, 4 gig, anything like that, that will typically be satisfied with a 10 gig port. As the time comes, those 10 gig ports will probably go away, and that traffic will either go over transit or over IX instead, unless 100 gig is an option for you. Because we have the same problem essentially with 100 gigs, although that is going to be the de facto standard, but at least the sacrificial factor is not as high on 100 gig. So we will still sacrifice 300 gig on a 400 gig port to produce a single 100 gig, and we are fine with that. We think that is an okay trade-off. One thing I would be interested to hear about, also in the coffee break, is single lambda 100 gig. It is basically natively supported on our side, and we use this optic for everything else. So for us, it's not a big thing to support it externally as well. And if anyone has any plans on this, I'm more than happy to listen in and see if it will make sense. Like the single lambda 100 gig optics are already cheaper than the typical 100 gig LR4s, even though the volumes are not there. So if we can get some volumes behind that, maybe that becomes like a super cheap option for 100 gig interconnect. And as I said here, we're not fully convinced this is a thing, given that on older style 100 gig platforms, these LR1s might not be supported. And if you need to buy new routers, then you might as well buy something with 400 gig ports, and maybe this problem goes away before it's even a problem, right? So, but I'm more than happy to speak with vendors, speak with SP, speak with whoever has opinions in this matter, and because I don't know, I don't know if this is going to be a thing. But I'm more than happy to support it if it becomes a thing. And seeing, this is me, I'm the RPKI guy as well, so I need to always speak about that, and I will use this conference to tout the horn as well on some of the routing security stuff. So AWS and RPKI, where we are today, I wrote a blog post a year ago or so, how we kind of do it. But the short summary is that we are dropping RPKI invalids in 100% of our internet edge border. In our 400 or so POPs. Every single eBGP session will drop invalids, regardless if it's transit, IX, PNI, or whatever it is. And today we have signed more than 99% of our announced IP space. We will probably comfortably hover around 99.9, because we do have a couple of prefixes which will never be signed, because we use those as monitoring for kind of how the ecosystem is working. And today, kind of how it works is that internally we have a vending machine. Every single internal team, if they want IP addresses for anything, like if they're building a new compute platform, or if they're, I don't know, doing something with advertisements or whatever, they go to the vending machine, they put in what is it today, $450,000 that gets the /24 out, and then they can use it, and then they can give it back if they don't need it anymore. And we take care of everything. They don't need to worry about RPKI, they don't need to worry about IRR objects, they just use the IP addresses, and we take care of kind of the logistics behind it. So that's how we set it up, and that also means that we have central control over everything, and also that we have on-call. For us, RPKI is not something that we just do for fun. For us, it's super critical stuff. So we have on-call teams on rotation that looks at all the RPKI data and all the signals that we see, and try to figure out, what to do with it. And if you're active on mailing lists and IETF and I don't know, RIPE database working groups or whatever, we are going places. We have quite big ideas of what we want to do with this. So one of the first and primary things, and the one I guess more that is relevant right now, is that we are looking and actually actively deploying the delegated RPKI solution, which means that we are moving our ROAS away from the RIRs and into our own system and our own publication point. We operate one of the largest CDNs in the world, so it would make sense that we use that infrastructure to also publish our own stuff, right? Today, we have migrated everything in APNIC and everything in RIPE, and hopefully by next year, or January next year, we migrate all of ARIN as well. And this is a significant part. It's roughly, globally, it's 3% of the IPv4 internet is under it's AWS networks, right? So This is a quite big thing, and I believe we are one of the first and certainly one of the largest to do this, and we're kind of figuring things as we go along on how to do this properly. And hopefully I'll be able to talk a lot more about this, kind of how the sausage is made, because this was not easy. Like, this is something we've been doing for at least 2 years, to move away from relying 100% on RARs to at least be able to do some of the things ourselves. BYOP, which stands for Bring Your Own IP Addresses, is, at least according to me, quite, I wasn't prepared there was such a popular service, but when looking at the numbers, everyone wants to bring their IP addresses to the cloud. And I see that this slide is already outdated as of last week, because the RSC IETF standard actually became a proper RFC last week. And I'm actively, or my team, I don't do anything, I'm just the hand-waving guy, but my team is building RSC stuff right now, which would help us with the whole BYP process on how customers can successfully bring their IP addresses where we can all agree that we trust each other, right? Like this, if you ever seen our BYP process, it's not very pretty. We do require RPKI and ROA signing for everything, but the part before that is not pretty, where we essentially import cryptographic keys into route objects. And sometimes those are forgotten in the route objects, and it kind of clutters the whole IR database. And we don't like it, but it was the only way we could do it back in the days when we invented this service. So we are active in IETF and other forums to make small improvements to this. Point number 3 there is that we will work and reach out to networks that has RPKI invalids to have them fixed, and that should go away. Like, we have stopped that. Like, if you have invalids in your network, then we're going to drop them, and if you don't fix them, then that's your problem, right? In the beginning, we were super cautious about this. We reached out to all the networks and like, hey, you have invalids, maybe you should fix them, or because we're going to drop them, and that means you have no connectivity to AWS. Maybe that's a problem or not. And some of them, they obviously reacted, but most people, they just ignored it. And we couldn't wait longer, so we just turned it on. And they still haven't gotten in touch, so maybe those networks are not used for anything. At least no customer is complaining, right? So we're not reaching out to networks anymore to fix this, because, you know, we didn't make a single exception. Like, certainly it was people that wanted us to do it, but we didn't do any exceptions. We didn't inject anything using, for example, Slurm. To fix this. The only fix for this was to fix the ROA. And yeah, we will continue to work on like community projects like Manners, for example. I'm the AWS representative in Manners. I'm part of the Manners Plus working group as well. And we think that this is a good way of being able to collaborate between networks and operators and companies that perhaps is not able to cooperate with each other in forums that doesn't have like a Manners type of functionality. So for us, it was great to be able to, we were part of the Cloud and CDN working group, and I can tell you it's fairly rare that those companies in that group can work together in a sensible way, but during the Manners project we could, which is great. And there is a couple of more community projects that I'm very interested in as well. I was part of the GSMA conference 2 weeks ago, and it seems that there is some routing security interest from that part of the world as well, which I'm very happy to be part of and learn in both directions on what to do. Fifth point here is to everyone's, I guess, great interest is that we also bring RPKI into all RFPs and RFQs going forward, as it will be a standard feature for all connectivity business. And the connectivity business is interesting. Like, it's not only about buying like IP transit for 16509. It's also, we have a couple of offices around the world. We have these fulfillment centers. Like, we are a pretty big buyer of connectivity globally. So getting this into RFPs and RFQs, same with IXs or whatever that carries IP addresses, right? Like it is, this will slowly be a part of that, which will hopefully also drive the industry a little bit faster forward. Like, we have done a couple of good things the last 2 to 3 years, I would say, where we actually see a great adoption of RPKI, but we don't want that to, you know, flat out. We will continue. We would like to continue to see that upward trends for increased routing security, and RPKI being one of the very central parts of that, at least in our opinion. So last slide. So get in touch. So find me. Like, I'm the guy that decides things in the UK. For any other thing, I guess use the regional aliases. There's quite common on like non-long mailing lists and whatever that the regular peering at will not answer. And that is absolutely correct. We use regional, or we have regional ownership everywhere. And that peering at email address gets roughly 2,000 emails per day. So it's just a sinking ship that we won't save it, right? So anyone that actually wants anything from us, use the regional aliases. That's the only way of getting in contact for like general questions. Our NOC has also gotten a lot of hate over the years, which I absolutely agree with. I was one of the biggest hater before I joined. And that was kind of my way in, right? I was hating so hard on the Amazon NOC that they were like, well, do you want a job? Eventually I got it, so it's still not fixed. But for peering inquiries, we have a new team actually called it Peering Tech Ops. And for the ones that has been in contact with them, hopefully it's been a joyful experience. But it's absolutely something which is our top priority to kind of get the operational stuff in a better position. Because it's the same thing, like the NOC, they handle like 5,000 tickets per day, and sometimes peering is not the most interesting thing for them to look at, or not the most important thing, given that we have, I don't know, 45,000 peers over the world, or 45,000 BGP sessions. So it's not, that's why we have a dedicated for just eBGP peering. Like the regular NOC, they handle everything from submarine cables to dark fiber outages or whatever it is, right? We also like when people use our self-service tools. So we are proud supporters and users of the NLog ring. We have nodes in every single cloud region that is part of the NLog ring trace program. And we use that a lot ourselves. And we would love for others to use it as well, use our boxes to do trace routes and pings and port scans or whatever it is. We also have the EC2 reachability matrix, with essentially a page that tries to do like a cross-region like reachability test, so that you have reachability to every single AWS region. It is linked to our PeeringDB page, and I would say that is one of our most powerful troubleshooting tools. And we will very soon launch a peering portal, where essentially you will be using either your PeeringDB account, or for certain ISPs, they will have another type of accounts where you can log in, you can see your sessions, you can see if there's any maintenance going on, and hopefully we can talk more about that roughly like Q1, Q2 next year, where we'll start to enroll basically everyone into the peering portal if that's something that's interesting. That's the end of my show.
Well, thank you very much. There's a lot of great content there. I really appreciate that. Thank you.
Thank you.